We now look at an example where our rational expressions have denominators that are polynomials. Let's find the LCD, or the least common denominator, for 17 over x squared minus 4 and 2x over x squared plus 4x plus 4. You want to remember that our first step will be to write our denominators in prime factorization form. That is, we want to factor x squared minus 4 and x squared plus 4x plus 4. X squared minus 4 is a difference of squares and factors as x minus 2 times x plus 2. X squared plus 4x plus 4 is a trinomial, and it factors as x plus 2 times x plus 2. Now we want to count the prime factors. Notice in the first factorization we have one factor of x minus 2 and one factor of x plus 2. In the second factorization we have two factors of x plus 2. So what's needed in our LCD? Well, we need one factor of x minus 2 because it appears in the first factorization. And we're going to need two factors of x plus 2 because the greatest number of times it appears in any single factor is twice. Multiplying the factors in our final column, we obtain x minus 2 times x plus 2 times x plus 2, which gives us x minus 2 times x plus 2 squared. And that is the least common denominator for our rational expressions. Now we move on to some trickier examples. Example 1c. Find the LCD for the list of fractions. 6 over x squared minus 4x and 3x minus 1 over x squared minus 16. In this example, notice our denominators are polynomials. But we're going to proceed with the same kind of process. We're going to factor our denominators first. So let's factor x squared minus 4x and x squared minus 16. To factor x squared minus 4x, we're going to take out the greatest common factor, which is x, from each term. That's going to leave us with x times the quantity x minus 4. To factor x squared minus 16, we observe this is a difference of squares. This factors as x minus 4 times x plus 4. Now we count the prime factors, the number of times each factor occurs in the factorizations. In the first factorization, there's 1x and 1x minus 4. And in the second factorization, there's 1x minus 4 and one factor of x plus 4. Now, what's needed in our LCD is the greatest number each time any one factor occurs in the factorizations. As far as x go, there's one x that we need to include. There's one x minus 4 that we need to include. And there's one factor of x plus 4 that we need to include. This means that our LCD is simply a product of those factors. 1x times 1x minus 4 times 1x plus 4. In other words, that simply gives us x times x minus 4 times x plus 4. That's our LCD for x squared minus 4x and x squared minus 16. Continuing on, example 1d. Find the LCD for the list of fractions. 7 over x squared plus 10x plus 25 and 4 over 3x plus 15. As before, we begin by factoring our denominators, in this case two polynomials. The first denominator, x squared plus 10x plus 25, is a trinomial, and that factors as x plus 5 times x plus 5. Our second denominator is the binomial 3x plus 15. To factor this, we want to take out the greatest common factor, which is 3, 3 factors into both of these terms. When you pull out a 3, you're left with 3 times x plus 5. Now we move on and count the prime factors. In the first factorization, there are 2x plus 5s. And in the second factorization, there's 1, 3, and 1 x plus 5. So what's needed in our LCD? Well, as far as x plus 5s go, the greatest number of times it occurs in any one factorization is 2. So we need 2 x plus 5s in our LCD. And the greatest number of times 3 occurs is once, so we need 1, 3 in our LCD. That means our LCD then, which is comprised of the objects in the third column, consists of 2x plus 5s and 1, 3. So let me write the 3 first, 3 times, and then 2x plus 5s, x plus 5, times x plus 5. We can rewrite this simply as 3 times x plus 5 squared if you like. Or you can leave it like the former. This is our LCD for the polynomials that have denominators x squared plus 10x plus 25 and 3x plus 15. This brings us to example 1e. Find the LCD for 17 over 8 minus a and 2 over a minus 8. Now, this one has a little trick to it. First, we begin by factoring each of the denominators. We're looking at 8 minus a and a minus 8. Let me start on the bottom. A minus 8. Well, that's actually a binomial and it can't be factored any farther. There's nothing that goes into a and 8, so it's simply its own factor, a minus 8. Now, 8 minus a. Well, it also doesn't have anything at first glance that goes into 8 and a. But if we rewrite this as negative a plus 8, when you look at it and rewrite it with the negative a first, you notice that you actually could take out a factor of negative 1. And when you take out a factor of negative 1 from negative a plus 8, it leaves you with a minus 8 inside the parentheses. Let's check it out. Negative 1 times a is negative a. Negative 1 times negative 8 is positive 8. So I'm going to factor 8 minus a as negative 1 times a minus 8. Now we proceed to count the prime factors in each of these factorizations. In the first factorization, there's 1 negative 1 and 1 a minus 8. In the second factorization, there's just 1 a minus 8. So what's needed in our LCD? Our LCD needs 1 factor of negative 1 and 1 factor of a minus 8. That means that our LCD is simply negative 1 times a minus 8. Or if you like, negative a minus 8, which if you multiply it in, you could also see that to be 8 minus a. Either answer works.